Imagine you're a sailor, miles from land, when a wall of water, taller than a 10-story building, rises from nowhere. It crashes with the force of 100 tons per square meter, enough to crush steel. These are rogue waves, freak giants that defy the ocean's rules, striking without warning and vanishing just as fast. For centuries, they were scoffed at as sailors' tall tales, lumped with sea monsters. But the evidence is undeniable now, and the stories? They're chilling. Let's start with Ernest Shackleton, the legendary explorer. It's 1916, and he's fighting for survival in the Antarctic's Southern Ocean. His ship, the Endurance, is lost to ice, leaving him and 5 others in a 22-foot lifeboat, the James Caird, on an 800-mile trek from Elephant Island to South Georgia. Storms batter them relentlessly. Then, one night, Shackleton spots what he thinks is a break in the clouds. It's not. He later wrote, "I realized that what I had seen was not a rift in the clouds but the white crest of an enormous wave. White surged the foam of the breaking sea around us. We felt our boat lifted and flung forward like a cork in breaking surf. That wave, estimated at over 100 feet, nearly ended them. Miraculously, they survived, but such stories were rare, and ridiculed. For hundreds of years, science dismissed rogue waves as impossible. Waves, they said, followed predictable patterns, maxing out at 30 to 40 feet in extreme storms. Linear wave theory ruled. Wind transfers energy to water, creating neat, calculable swells. Tales of giants taller than ships were mocked, sailors branded as fantasists. But as ships grew sturdier, would giving way to steel, the reports piled up. Between 1969 and 1994, 22 supercarriers, massive cargo ships, vanished, likely to rogues, taking 525 lives. The ocean was hiding something science couldn't ignore. Take the MS München in 1978. This 240-meter German cargo ship, built to handle 15-meter waves, was crossing the North Atlantic in a fierce storm. At 3:10 a.m. on December 12, an SOS crackles out, heavy seas. Damage to bridge. Then, nothing. A search involving 13 planes and 100 vessels finds only debris. Months later, a lifeboat is recovered, not launched, but ripped from its mount 20 meters above the waterline, steel pins bent like straws. Experts now point to a rogue wave packing force far beyond the ship's 15-ton per square meter design limit. It was a wake-up call, but skepticism lingered. Then, proof crashed through. In 1980, Philippe Leger photographed a rogue wave off South Africa's coast, a blurry but undeniable wall of water. The clincher came on January 1, 1995, at the Dropner oil platform in the North Sea. Amid 11-meter waves, its laser sensor recorded a 25.6-meter monster, over twice the significant wave height, the average of the tallest third of waves nearby. Engineers had pegged a 20-meter wave as a once-in-10,000-year event. The Dropner wave blew that math apart, forcing science to rethink everything. Rogues were real, and they were rewriting the rules. So, what is a rogue wave? It's a freak swell at least twice as tall as the significant wave height, often steeper and from an unexpected direction. They're not your typical storm waves, nor like the predictable giants at Nazaré, Portugal, where underwater canyons create rideable 28-meter swells. Rogues strike in deep water, defying forecasts. The first official report dates to the 1820s, when French explorer Jules Dumont d'Urville spotted 30-meter waves in the Indian Ocean, backed by 3 witnesses. He was laughed off, even by France's prime minister. For 150 years, linear wave theory held firm. But as ships survived more encounters, the stories grew undeniable. In 1995, the Queen Elizabeth II cruise ship was slammed by a 27-meter rogue en route to New York, shattering windows 21 meters up. The captain likened it to hitting the white cliffs of Dover. In 1997, the Tokyo Express tilted violently off the UK coast after an 8.5-meter hit, spilling 5 million Lego pieces into the sea, ironic sea-themed toys still washing up today. These incidents spotlight another ocean issue, pollution. Plastic from wrecks like the Tokyo Express joins the microplastics clogging our seas, infiltrating food and water. It's daunting, but collective action helps. Groups like Planet Wild crowdfund projects, like cleaning Albania's plastic-choked rivers, with video updates showing real impact. I'm part of it, and if you use my code ASTROM9, I'll cover your first month for the first 100 signups. Check the link or QR code below, see change in 30 days. Rogues kept making waves. In 2000, The RRS Discovery off Scotland measured a 30-meter giant, the tallest in open ocean then. Weather models missed it entirely. In 2007, NOAA linked 50 ship incidents to rogues. In 2020, a buoy near Ucluelet, British Columbia, caught a 17.6-meter wave, triple the surrounding swells, a 1 in 300-year anomaly. These aren't just numbers, they're proof of nature's unpredictability. So, what causes them? Science hasn't nailed a single answer, but here's the rundown. First, constructive interference. Waves of different speeds and directions overlap, their crests stacking into a mega wave, then dispersing. Think of it like waves high-fiving for a fleeting monster. Second, ocean currents. When storm waves hit an opposing current, like the Gulf Stream or South Africa's Agulhas, they compress, steepening into towers. The Agulhas, flowing at 5.8 miles per hour, can amplify waves by 60%, sinking 150 ships in recent decades. Third, nonlinear effects. In chaotic seas, a wave can steal energy from neighbors, ballooning until it collapses. In 2012, researchers used a Lego pirate ship in a wave tank to prove this, showing one wave hogging energy, published in scientific reports. Which theory grabs you? Interference's randomness, currents geography, or nonlinear's chaos? Share in the comments. But rogues aren't shorebound giants like Nazareth, shaped by seafloor canyons. They're deep ocean wildcards. Where do they strike? Anywhere, really, that's the fear. Hotspots include the Agulhas region, where ships now detour in storms, or the Gulf Stream, possibly tied to Bermuda Triangle vanishings, see our video on that. The Drake Passage, Shackleton's Gauntlet, is another breeding ground. Predicting them? Tough. University of Maryland's neural networks, trained on millions of buoy readings, can flag rogues 5 minutes out, in tests. But the ocean's chaos keeps it tricky. Rogue waves are nature's paradox, breathtaking, bone-crushing. They hit with forces that can crumple cruise ships. Yet, modern ships are tougher, reinforced hulls, better forecasts. From 2011 to 2018, only 210 rogue incidents were reported globally. The last major sinking, the MS Munchen in 1978. Your odds of meeting one? Slimmer than a lottery jackpot. Still, next time you're at sea, keep one eye on the horizon. Thanks for diving in. If rogue waves sparked your wonder, hit like, subscribe, and tell us, what's the next ocean mystery to unravel? Kraken, vents, you name it. See you soon.